Then we get to simplify an expression using the trig functions, using the trig identities. So the first one is simplify sine theta cosecant theta over cotangent theta. So we're going to try to simplify this. Hopefully we can see that it can be simplified to a single trig function. So as I look through my basic trig identities, one of the things I recognize is that sine and cosecant are reciprocal identities. Sine and cosecant are the reciprocal identities right there. So what I'm going to do is I'm going to rewrite sine theta as 1 over cosecant theta. So sine of theta, I'm going to replace sine of theta with 1 over cosecant theta. And that's being taken times just cosecant theta over cotangent theta. And what happens is if I have 1 over cosecant times cosecant, those cancel each other out. So I'm left with just 1 over cotangent theta. And again, as I look through my reciprocal identities, I look right here. Tangent theta equals 1 over cotangent theta. So I'm going to replace 1 over cotangent theta with what it equals, tangent theta. So saying tangent theta is a whole lot easier than saying sine theta cosecant theta over cotangent theta, and they are equivalent to each other. So that's what it means to simplify an expression, is try to get one trig function that is equivalent to a bunch of trig functions that might be added, subtracted, multiplied, or divided together. Let's try some more. So this one is tangent squared theta cosecant squared theta minus 1 over secant squared theta. So it does take a little practice to do some of these, and you do have to be familiar with some of the trig identities. So as I look through this one, I look at tangent squared theta and I look at cosecant squared theta. And one of the things I see about tangent of theta, it is equivalent to sine over cosine. And another thing I notice is cosecant squared theta. Cosecant theta has a reciprocal function of 1 over sine. So that's where I'm going to start with this one. I'm going to rewrite tangent theta as sine over cosine. And since it's tangent squared theta, I'm going to rewrite that as sine squared theta over cosine squared theta. So I'm going to rewrite tangent squared theta as sine squared theta over cosine squared theta. That's going to be taken times the reciprocal function cosecant of theta. So now that's going to be 1 over cosecant squared theta, sine squared theta. Now notice I didn't square the 1 because what's 1 squared? Still 1. And then minus 1 all over, and then it is secant squared theta at the bottom. Probably going to have to do something with that here in a second. I will cancel out the sine squared thetas. So that leaves me with 1 over cosecant squared theta minus 1 over secant squared theta. Okay, let's look at what else we can find here. Well, secant squared theta, it is the reciprocal. Secant theta is the reciprocal of 1 over cosine. So I'm going to go ahead and replace that secant squared theta with 1 over cosine squared theta. So that means I have 1 over cosine squared theta minus 1. All of that is going to be over 1 over cosine squared theta. Dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to rewrite that as 1 over cosine squared theta minus 1. And I'm going to take this times the reciprocal of 1 over cosine squared theta, which is in the denominator, which is just cosine squared theta. And then I have to do the distributive property. So when I do the distributive property, I have 1 over cosine squared theta times cosine squared theta, which means cosine squares thetas will cancel each other out for that portion of it. So I'm left with just a 1. And then I have to take cosine squared theta times -1, which will give me negative cosine squared theta. And where have we seen 1 minus cosine squared theta before? So as I scroll back to the very top, it was right here. Sine squared theta equals 1 minus cosine squared theta, and that's exactly what I have right here. So I'm going to replace 1 minus cosine squared theta with what it equals, and it equals sine squared theta. So that is the simplified form of the original problem, which was tangent squared theta cosecant squared theta minus 1 over secant squared theta. Let's try another one. 2b is secant theta sine theta over, or times 1 minus cosine squared theta. Well, there's that 1 minus cosine squared theta again. So let's rewrite this as secant theta sine theta times 1 minus cosine squared theta is the same as sine squared theta. Sine theta at the denominator will cancel out with one of the sine thetas on the numerator here. So that means I'm left with secant theta sine theta. Now, if this was secant and cosine or cosecant and sine, this would be very easy because they're reciprocal functions of each other and they would cancel each other out. However, we have a secant and we have a sine, and they are not reciprocal functions of each other. But I can still use reciprocal functions because secant can be rewritten as 1 over cosine. So secant I'm going to replace with 1 over cosine theta. So I have 1 over cosine theta times sine of theta. That means I have sine theta over cosine theta. And again, looking through my identities, where do I see sine theta over cosine theta? Oh, look, it's right here. It's one that we've already used. Sine theta over cosine theta equals tangent theta. So this simplifies to just tangent theta. Finally, there's a lot of real-world examples we can use these trig identities with. The amount of light that a source provides to a surface is called its illuminance. The illuminance E in foot candles on a surface is related to the distance r in feet from the light source. The formula secant theta equals I over ER squared, where I is the intensity of the light source measured in candles, and theta is the angle between the light beam and a light perpendicular to the surface, can be used in situations in which the lighting is important, as in photography. Solve the formula in terms of E. So let me first rewrite the problem. It is secant theta equals I, that is capital I, don't confuse that with square root of -1, which is small I, equals over ER squared. And we are to solve this in terms of E. So I got to get the E by itself. So get the E by itself, I could start out by dividing or multiplying both sides by ER squared, and that will eliminate the fraction. So I have ER squared secant theta equals I. And then I will just divide both sides by R squared secant theta. Just secant theta, not secant squared theta. So R squared secant thetas cancel, so I have it solved for E. E equals I over R squared secant theta. So that's part A. Part B, is the equation in part A equivalent to R squared equals I tangent theta cosine theta over E, and explain. Okay, well, I'm going to first start by trying to solve that for E, so that just like the other one solved for E. So to solve that for E, it would be a matter of multiplying both sides times E to cancel out the E's. So that would give me ER squared equals I tangent theta cosine theta. And then I would divide by R squared. So I would have E equals I tangent theta cosine theta over R squared. So it looks like on the surface that they are not equivalent to each other because above I have I over R squared secant theta. But let's look at what we know about tangent theta and cotangent theta. So we know tangent theta equals sine over the cosine. That's going to be pretty handy because that will help us cancel out the cosine. So I'm going to replace tangent with sine over cosine. So sine theta over cosine theta times the cosine theta over R squared. So the cosines eliminate each other. So I have E equals I sine theta over R squared. The related reciprocal function of sine of theta is actually cosecant theta. So I'm down to E equals I sine theta over R squared. And as I go up here, is there any way I can relate sine with secant? So as I go through some of these trig identities, I do see sine related to cosecant right here. Of course, sine and cosecant are related to each other. Cosine is related to secant. I don't see any place here that I can relate sine to secant. So actually, the equation that we have here at the start of part B is not equal to the equation we ended up with in part A. So this is a no. They are not equivalent to each other. And the work here that I've shown is the explanation as to why they are not equivalent to each other.